In these last two examples, we want to look at tying all of these concepts together to be able to sketch the graph of a function only given the function itself. To start off, we'll look at identifying all real zeros, which is the same thing as finding our x-intercepts, meaning we'll take x plus 9 equal to 0 and x minus 3 equal to 0. So we'll have an x-intercept, or real zero, at x equals negative 9 and at x equals positive 3. We want to consider the multiplicities of these zeros. We have x plus 9 to the first power, so we have a multiplicity of 1, and x minus 3 squared, so we have a multiplicity of 2. Keeping in mind that odd multiplicity means our function will cross over the x-axis, and that even multiplicity means that our function will touch the x-axis and then curve away without crossing over. We also want to identify our y-intercept, which we can do by evaluating f of 0. So meaning we're setting our x value equal to 0 to see what our corresponding value is for y. This will give us 9 times 9, or 81, as our y-intercept, meaning the point 0, 81. We also want to consider what's happening to our function for extreme values of x, so as x approaches positive or negative infinity. What we can see is that f of x is approaching x times x squared, meaning its end behavior will behave similarly to x cubed. So as x approaches infinity, f of x will be approaching infinity. And as x approaches negative infinity, f of x will also be approaching negative infinity. Now we want to take that information and use it to sketch the graph of our function. Again, we know that we have x-intercepts occurring at negative 9 and at positive 2. We know we have a y-intercept occurring at 81, which will be just a little bit past 80. We know that as x approaches infinity, our function is going to be headed to positive infinity. As x approaches negative infinity, our function is going to be headed towards negative infinity. The next thing to do then is to use that information along with the multiplicities to sketch out the behavior of our graph. We know that it can only hit the x-axis at negative 9 and at 2. We know that we have an odd multiplicity at negative 9, and our function has to come from this decreasing portion, or this portion that's headed to negative infinity. We have to make our way up to negative 9, where we'll cross over. We have to hit this y-intercept, and at x equals 2, we have an even multiplicity. So our function is going to hit that point and then curve back away. And then as x continues to increase, we have to be headed off to positive infinity. So this would be a rough sketch, and it's important to keep in mind is that what we're doing is just sketching the graph of our function to make sure we have the end behaviors represented and the behaviors at our intercepts represented, and that we're also intersecting with that y-intercept. Some things that we don't know is where any extrema occur, and what the rate of change of our function is at any given point. So that means we don't really know how steeply or narrowly to draw some of these different curves. We don't know exactly where this function should change direction, though we do know if we have an even multiplicity, that has to be at least one extremum, one turning point. So we have some unknown pieces of information that we just kind of have to gloss over. But if you make your way to calculus, you'll pick back up with this idea of curve sketching, revisiting this topic and adding in some of these additional missing pieces, identifying all extrema and understanding the rate of change at different values for x. For example 8, we'll repeat that same process. We'll first look at identifying all of our real zeros, which in this case will be x equals -3 and x is equal to +4. These both have a multiplicity of 2, since both factors are being raised to the second power. And we could evaluate g of 0 to obtain 144, meaning we have a y-intercept at 0, 144. As x approaches positive and negative infinity, so when we consider those extremes, our function is approaching x squared times x squared, or x to the 4th power is the behavior that we're mimicking. So as x approaches positive infinity, g of x will approach positive infinity, and as x approaches negative infinity, our function still approaches positive infinity. Again, what we want to do is sketch a graph that mirrors those specific characteristics that we just identified. We have an x-intercept at -3 and another one at +4. We know that in each of these cases we have an even multiplicity, so we won't cross over the graph there. We know that our end behavior is headed off to positive infinity at both ends. And we have an x-intercept at 144, which is a little bit less than halfway between 100 and 200, so we'll plot that about there. So this means that our curve has to hit this y-intercept. When we hit our x-intercepts, because of those multiplicities, our function is going to touch and then curve away from the x-axis. And then we just need to make sure that at either endpoint, that the end behaviors are both headed off to positive infinity, and then just fill in roughly what we can identify to make sure we're representing those different behaviors that we identified above. I, for one, am not great at drawing, which you can probably tell from these different curves that I've sketched out. But again, the important ideas are to make sure we're representing the correct behavior at each of our intercepts, that we have those x and y intercepts represented, and that our end behavior is heading in the direction that we would expect, given the information that we can extract from that function.